told there are only red sweets and yellow sweets in a bag. There are n red sweets in the bag and 8 yellow sweets in the bag. Sajid is going to take at random a sweet from the bag and eat it. He says that the probability that the sweet will be red is 7/10, and we need to show why the probability cannot be 7/10, and this part is worth 1 mark. Okay, let me show that straight. So to begin with, okay, the number of red sweets, or the probability of red, okay, so where's my black pen? Yes, we can say P red equals n over n plus 8, okay, and we're going to let this equal his fraction of 7/10. This means that we have 10n equals 7n plus 56, 3n will equal 56, and this means that n will equal 56/3. Now this isn't a whole number, okay, which means that it can't be n because n is a number of sweets, okay, so we can say here n must be whole, 56/3 is not, therefore n, because n is the number of sweets, therefore n cannot equal 56/3, and so P red is not 7/10. So this part is worth 3 marks. The first mark comes from stating that the probability of a red algebraically is n over n plus 8. Second mark comes from expanding this, so solving this fraction to remove it to get this, and third comes from getting that n equals 56/3 and writing a conclusion. We are then told, after Sajid has taken the first sweet from the bag and eaten it, which means it's not replaced, he's going to take at random a second sweet from the bag. Given that the probability that both of the sweets he takes will be red is 3/5, work out the number of red sweets in the bag, and we must show all of our working, and this part is worth 5 marks, okay? So, what we're going to do is we're going to say, initially, P red equals n over n plus 8. Like this. After one has been taken, so we're going to say initially, okay, and then after one is taken, so 1 red, this is going to be n minus 1 over n plus 7. So we know that if these two occur, then the probability will be 3/5, sorry. So what we're going to say is n over n plus 8, so the probability the first one is red, and the probability the second one is red, so finding the product like this, equals 3/5. We're going to expand this, solve the quadratic, and get it in terms of n, okay, see how many sweets we have. We will say that n times n minus 1 over n plus 8, n plus 7 equals 3/5. Right, we'll cross multiply to get rid of our fraction, so we'll say n minus 1 times 5 equals 3 times n plus 8, n plus 7. We will now get 5n squared minus 5n equals 3n squared plus 8n plus 7n is 15n plus 8 times 7, which is 56. Okay? Expanding this, we get 3n squared plus 45n, and then 56 times 3 is 168. Now, what we will do is we'll just come to the new page, and we will rearrange this. So we will say that we have 2n squared minus 5n minus 45n is minus 50n, so minus 50n minus 168 equals 0. We will divide both sides by 2 to get n squared minus 25n, and then 168 divided by 2 equals 84, minus 84 equals 0. And then we will use our quadratic formula, okay, and the quadratic formula is minus b plus or minus the square root of b squared minus 4ac all over 2a gives us our two roots, okay, our two solutions. So plugging this in, we will get that this is minus 25 plus or minus the square root of 25 So minus 25 squared minus 4 times 1 times minus 84 all over 2 times 1, which is just 2. Okay? This will get you that n either equals minus 3 or n equals 28. Now, n is the number of sweets. We can't have negative sweets, so we have to state here that n has to be greater than 0, and in turn, n equals 28. So this part is worth 5 marks. The first mark comes from stating somewhere that you're using the two fractions n over n plus 8 and n minus 1 over n plus 7, so that's your first mark. Second mark comes from creating this fraction. Third mark comes from clearing this fraction to get a quadratic in this form. Fourth mark comes from solving this quadratic, so using the quadratic formula. Okay, so fourth mark. And then fifth mark comes from getting 28 as your final answer.